Hello everyone. Today we are going to solve most important PYQs on heat and power. I hope you have already watched the part 1 video in which we learned some tips to solve the numericals. Link is given in the description. Let's see the first question. Two identical resistors, each of resistance 2 ohm, are connected in turn in series and in parallel to a battery of 12 volts. Calculate the ratio of power consumed in the two cases. Let's see the first case, that is in series. Two resistors are connected in series. We have three formulae to find the power consumed. As the total power is asked to find out, we can easily use the formula P is equal to V square divided by R without calculating the current. So, power consumed in series combination is equal to V square divided by equivalent resistance in series combination. Equivalent resistance is equal to sum of the individual resistors, that is 4 ohms. By substituting the values, we will get the power consumed. The total power consumed in the series combination is equal to 36 watts. Here is the alternate method. Here we need to find the value of current also. We have already found the value of RS. Current is equal to applied voltage divided by equivalent resistance. Here equivalent resistance is 4 ohms. Then the current I is equal to 12 volt divided by 4 ohms, that is 3 ampere. By using the formula I square R, we will get the same power as 36 watts. Now let's see the second case, that is in parallel. Here also we can use the same formula. Power consumed in the parallel circuit is equal to V square divided by equivalent resistance in parallel combination. And by using the formula to find equivalent resistance in parallel combination, we will get Rp as 1 ohms. We can also use the other formula, that is these resistors are identical. Means if n identical resistors are connected in parallel, the equivalent resistance will be R divided by N, where R is the resistance of each identical resistor. Then also we will get the same value as 1 ohm. Now we are substituting the values in the formula. Then the power consumed will be equal to 144 watts. We can also use the alternate formula, that is P is equal to I square R, but then we need to find the value of current first. That is using the formula V divided by Rp, we will find the value of current and then substitute the value of current in I square R. So we got the two values. In series, power is equal to 36 watts. In parallel circuit, power is equal to 144 watts. So the ratio of power consumed in the two cases is 1 by 4. Means power in parallel combination is 4 times that of power in series combination. So there is a similar question in the electricity NCERT exercises, question number 4. Please practice the question. Here is the second question. Compare the power used in 2 ohm resistor in each of the following circuits. A series circuit and a parallel circuit are given, in which two resistors are used, 1 ohm and 2 ohm. And the supply voltage in series circuit is 6 volt. That in parallel circuit is 4 volt. Let's find the power consumed in 2 ohm resistor individually. Let's see the series circuit first. Power consumed by 2 ohm resistor is equal to I square R. As we have already seen in the previous video, it is easy to use I square R formula for series circuit to find the individual power. We need to find the power used by 2 ohm resistor. Therefore, I square into 2 ohm. So next we need to find I. For that, equivalent resistance is equal to 2 plus 1, that is 3 ohms. Current I is equal to V divided by RS, that is 2 ampere. Then substitute the values in power equation. Then we will get the power consumed in 2 ohm resistor as 8 watts. So next let's see the parallel circuit. Here we can use V square divided by R formula easily without finding the value of current. Power consumed by 2 ohm resistor is equal to voltage across 2 ohm resistor square divided by resistance. That is 4 into 4 divided by 2 ohm, which is equal to 8 watts. Same power is consumed by 2 ohm resistor in both combinations because of different voltages applied. Let's see the third question. An electric bulb is rated 100 watts at 220 volt. When it is operated on 110 volt, what will be the power consumed? The bulb consumes 100 watts when it is operated on 220 volt. We need to find how much power will it consume when it is connected to a 110 volt supply. It is given in the question that for an operating voltage 220 volt, V1 is equal to 220 volt, the power is V1 square divided by R, which is equal to 100 watts. The resistance of the bulb will remain constant even if we connect it to a different supply voltage. Therefore, let's find the value of resistance. Resistance of the bulb R is equal to V1 square divided by P1. That is 220 square divided by 100. Now let's see the operating voltage V2 is equal to 110 volt. Power consumed will be V2 square divided by R. That is 110 into 110 divided by resistance of the bulb. By substituting the values, we will get the power consumed by the bulb on 110 volt is 25 watts. Here is an alternate method. We know that V1 is equal to 220 volt. The power consumed on this voltage is 100 volts P1. V2 is equal to 110 volts and we need to find P2. We know the formula P is equal to V square divided by R. The resistance of the bulb is constant, which means power is directly proportional to square of the applied voltage, which means P1 divided by P2 is equal to V1 square divided by V2 square. By substituting the values, we will get the same answer. That is, power consumed is equal to 25 watts. Let's simplify. When the voltage applied is reduced by half, then the power consumed will become 1/4 of the initial power. Let's see the fourth question. Two electric lamps of 100 watts and 25 watts respectively are joined in parallel to a supply of 200 volt. Calculate the total current flowing through the circuit. Here is the circuit diagram. We need to calculate the total current flowing through the circuit. Given that the applied voltage is 200 volt, power of the first bulb P1 is 100 watts, P2 is equal to 25 watts. And the total power will be equal to P1 plus P2, which is equal to 100 plus 25, that is 125 watts. We know the formula P is equal to VI. From this formula, we can find the total current, which is equal to P divided by V. That is 125 watts divided by 200 volt, which is equal to 0.625 ampere. Here is an alternate method to find this. Let I1 be the current flowing through 100-watt bulb and I2 be the current flowing through 25 watts bulb. Then we can use the formula P is equal to VI. I1 is equal to P1 divided by V1, which is equal to 100 volts divided by 200 volt, that is 0.5 ampere. I2 is equal to P2 divided by V2, that is 25 volts divided by 200 volt, which is equal to 0.125 ampere. And the current divides into two branches. Therefore, the total current I is equal to I1 plus I2, means 0.625 ampere. Using these both methods, we will get the same answer. Let's see the fifth question. Two electric circuits 1 and 2 are shown below. If R1 is greater than R2 is greater than R3, in which circuit more heat will be produced in R1 as compared to other two resistors? It's a tricky question. Before solving this question, let's do a recap of the previous video, that is part 1. We have seen this conclusion. If two resistors are connected in parallel, the voltage across each one is constant. So, the power is inversely proportional to resistance of the bulb. Means in their parallel combination, the bulb which has less resistance will consume more power. In series circuit, the current through each bulb is constant. Therefore, the power is directly proportional to resistance of the bulb. Means the bulb which has more resistance will consume more power. So, let's solve this question. We know the formula of power. Heat is equal to power into time. In the circuit 1, current through each resistor is constant. So, let's use H is equal to I square RT. As I is constant, heat is directly proportional to resistance. So, the resistor having higher resistance will consume more power and also dissipate more heat. When R1 is greater than R2, which is greater than R3, then heat produced by R1 will be greater than R2, which will be greater than R3. We got the answer, but still, let's see the second circuit. Voltage across each resistor is constant. H is equal to V square by R into T. And so H is inversely proportional to resistance because voltage is constant. So the resistor which is having higher resistance will produce less heat. When R1 is greater than R2 is greater than R3, H1 will be less than H2, which is less than H3. In the question, in which circuit more heat will be produced in R1 as compared to other two resistors? It's clearly visible that in the first circuit, the heat produced in R1 is greater than that in R2 and R3. So, the answer is circuit 1. Here, the heat produced in R1 is taken into consideration as compared to other two resistors. But we are already seeing that the total power consumed and total heat developed will be higher in parallel combination, means the total power. Here is an example. In which circuit the total heat produced in time t will be maximum. Here, we need to consider the total heat produced. Here, same voltage is applied across each combination, the series combination and the parallel combination. Heat is equal to V square divided by R into time. R is the R equivalent, means as the V is constant, heat is inversely proportional to equivalent resistance of the system of resistors. So, we know that Rs is greater than Rp. Equivalent resistance in series combination is greater than that in parallel. So, Hs will be less than Hp, means the total heat produced in circuit 2 is maximum, which is the parallel combination.